All right, so let's get started. Welcome to this presentation. Despite what the background picture may suggest, we're not here to talk about Lisbon Coast, but instead it's a live update. So for the next 30 minutes, I'll share with you how we have finally designed this solution and some options we have considered to make the solution even faster. So as the long title reads, this presentation is about replacing the hypervisor with limited downtime. And so I want to make things clear. It is not about updating anything in DOM0 or the device model or XenStore or anything else, but solely about replacing the hypervisor. And so a few years ago, some colleagues came and they had a very fluid design. Nothing was set in the stone at that time. They were looking for feedback and advices, which they eventually got. Fast forward a few years later, Julien made a good presentation about what we had at that time. And he even made a good demonstration. But since that, a few things have changed, and I assume that maybe not all of you have attended those great presentations. So I suggest we start first with a brief refresher of live update, how that works, and why do we need such a tool. So I couldn't wish for a better introduction this morning when Marcus said that for a customer, downtime is equal to money, and we can't afford to sometimes just interrupt the guest workloads. So now let's imagine we have to replace the hypervisor with keeping the guest workloads running. We don't have many options. The first one you might consider is live patching. But with live patching, you won't be able to completely replace the hypervisor. It is, though, a very good solution to apply simple band aid, and during a security issue, it is very easy to apply the hot patch. But the bigger the change is, the more complex it becomes, and you would probably not want to completely replace the hypervisor applying hot patches on top of that. The other thing you might consider is live migration. And so you could potentially migrate all your guest domains from one server to another, and while it is empty, you could just reboot it and land on the new version of Xen. But, and then eventually migrate back those guest domains on the original server. But that is guest dependent. I don't think upstream we have the guest transparent live migration. And on top of that, transferring a guest domain is not cheap. It takes quite a bit of time to transfer that about the network. And so, well, that's a bit of a headache. So live migration is still a great tool. And if we see it a different way, instead of migrating the guest domain physically from a server to another one, we could just migrate them on the same server. And this is a bit the idea behind live update. So live update is the alternative we have worked on for the last few years. It is a 7-step process, and I will detail them later during the presentation. It is also great because it is transparent to guest domains. We don't need any guest cooperation. It happens without the guest even being able to notice it. Well, I shouldn't say that because it's overselling the project, but basically we have a very limited downtime. So guests would probably not realize that the underlying hypervisor has changed. So yeah, it's quick, really quick, and I will share some figures later on. All right. So what I will first do is walk you through the steps that makes up Xen Live Update. So let me set the stage. With 4 CPU, 2 domains, DOM0 and 1 DOMU. On the right-hand side of the slide, you can have a memory representation of what the system is. And so we have Xen 1, and then a tiny piece of memory, which we call the live update with memory. And I will cover that in details later, but this is very useful. And then naturally, the memory that belongs to both guest, DOM0 and DOMU. So it will be a high-level overview of how that works, and I will simplify a few things. And the simplification begins now. To request live update, we issue some hypercall, but everything has been wrapped in a nice script to make the life of the operator easier. So eventually, we would like to do live update, and the request is issued from DOM0 to Xen. And so the first thing we need to do is to load Xen 2. And as we would do with anything we have to load in memory, we just look for enough space free somewhere, allocate that, and once we found that space and it is allocated, we can just load the binary there. But we're not here yet. I mean, we can't just jump onto Xen 2. We have to preserve some state, as we would do with live migration. So this is one of the things that has changed since the last time we made the presentation on live update. If you pay a bit attention at the system, we now have a tasklet running on CPU 0. This is not a requirement. It could be any CPU, but this is what I've chosen to do. And so the tasklet here is meant to start serializing Xen 1 state. By the way, by Xen 1 and Xen 2, I mean Xen 1, the currently running version of Xen, and Xen 2, the version we would like to be running on. So as I said, the CPU 0 is now freed from running DOM 0, and DOM 0 has one less physical CPU where it could run. So it is in what we like to call degraded mode. And so with the tasklet, we're going to save key things we can do before the pause of the domain. And so there are plenty of things to save, and some of them are quite likely to change. So we can't save everything before the pause. But after doing some live update, we have noticed that some stuff are unlikely to change. And this stuff is the memory of the domains we have to transfer, especially for the HVM domain. This is not true for PV because PV changes quite a lot. But in the case of DOMU, it is quite easy to transfer that before the pause of the domain, or to save that, sorry. So this is a virtual representation of what the memory would look like. But physically, it's less attractive, let's say. The memory could be a bit more fragmented. And so, well, there is not legend for the colors, but orange would be for one domain, then blue for the other. And so, as I said, it's quite fragmented. But still, for DOMU, for HVMW, sorry, it is unlikely to change. So what we do is that we keep memory in place. We don't have to copy that over again and save that into a stream or anywhere. So memory remains in place, and we only transfer the page info. So this is to say, this domain owns that page, and we do that with the page info. But even though we just save the page info that makes up the guest memory, it is still expensive to save. We have to iterate through all of the page infos, and yeah, it is expensive. The good thing, as I said, it is unlikely to change, so we can afford to do that before the pause of the domain. And so eventually we can save that and put that just next to each of the domain. I shouldn't have put the orange bar for DOM0 because it's a PV. Just realized my mistake. Sorry about that. So now that with the tasklet we have saved what we can save before the pause of the domain, we can now proceed to pause the domains. And here too, we cannot pause the domain at any time. We need to be in a safe condition, which means that there cannot be any I/O in flight, because if the DOMU issue a request to write, let's say, in a disk, and QEMU hasn't responded, we can actually pause the domain and restore that later to be in a weird state. So we want to make sure that there is no I/O in flight. And if we can't quiesce the domain because, let's say, QEMU is not responsive, or in worst case, QEMU is not even running anymore in DOM0 because it has crashed for some reason, then we have a mechanism to bail out and cancel live update. But let's say that in that case, we could have quiesced everything correctly. So now we can save the rest of the states that are more likely to change and that we couldn't have saved during the pre-save operation. And this is again done in a tasklet. I should have made it a bit more explicit, but it is a different tasklet that is scheduled on the CPU 0. Of course, we cannot do that in the hypercall context. It would be way too long. So regarding the way we save that, it is just some simple page that we would allocate somewhere in memory. And the key thing is that we have to keep track of all those pages that contain the Xen 1 state and the domain, the guest domain states. And so we store that into what we call the stream page list. It is basically a list of pages that makes up the stream. And this is the key thing we have to transfer to Xen 2. And so let's have a closer look at what we decided to call the live update with memory. So it begins with the magic number, because obviously we have to somehow check in Xen 2 we are looking at the correct location. And then after, the page list method, which is equivalent to the stream page list, it is the list of pages that makes up the stream. Then we also transfer the number of pages we have to make the stream, and then some free memory. So this free memory is used for a few things. If the Xen 2 binary is bigger than Xen 1, then we could use some bytes there. Also, during the early stage of the boot for Xen2, we cannot allocate pages from anywhere. It could belong to a guest which has been paused, or it is maybe just a page that makes up the stream. So during the early stage of the boot for Xen2, we will just use this free memory until we have the stream mapped and we know what page we can use or not. All right. So now we have pretty much everything saved, and we can just proceed to jump to Xen2. And we do that using kexec. So the way Xen2 will know about the stream we have saved is because we have an additional argument on the command line. So Xen2 will know when booting and parsing the command line, where is the live update memory, and do its own thing. So let's go. Nice animation. Xen2 is now in place, and we have jumped there. And we can now proceed to restore and resume the domains. And so from step 4 to step 7, when we have finally resumed the domains, this is what we call the downtime, where the guests are not running. Yeah, I have removed the post sign. All right, so this is it about replacing the hypervisor, and I would be happy to take any question before going any further, if there are some, of course.
What happens if you use PCI task to all the IO values and etc.?
Good question. I was somehow anticipating it. Well, knowing they would get that. So we can't post the devices. The devices are still running, and so this is why we have to preserve the IO memory tables. And so we might have missed some interrupt while we're pausing the domains, and the thing we do is that when we land in Xen2 after having resumed everything, we inject some virtual interrupt. And so we will go through the handlers of each interrupt we may have and see if there is some work to perform or not. And so that's how we do it. We don't have any mechanism to queue the queues. Any other question?
In pre-save,
Yes.
you say that you save page info there's unlikely change.
Yes.
Does not mean it is impossible to change.
You're correct.
Deal with changes.
So we basically just have a flag to make sure that as soon as we have requested live update, well, I mean, from the time where we have requested live update until we decide to post the domains, nothing has changed. If a page has been returned to Xen or a new page has been allocated, then the flag would be raised. And so we would know after posting the domains that something has changed, and we would just bail out and cancel live update.
Oh, so cancellation is
The answer, yeah.
And I have a second question.
Yes?
From taking the presentation as it is, you give the impression as if page info was the only thing that needs preserving.
No, of course not. But I can't go through all the other items we have to save. That would be boring, and that wouldn't bring much value. But of course, there are plenty of other things we have to transfer.
Yeah, I mean, it's not just transfer, it's translate. Because the new version of Zen may have a different layout of all the current structures.
That's correct. This is what we try to do. Try to keep the stream hypervisor agnostic. Sorry. So we, well, I shouldn't say that, but anyway, we could in theory land to a completely different version of Xen that has a different interpretation of few things. So yeah, the stream has to be generic.
Okay, so you basically canonicalize information in a certain.
Yeah, at least this is what we try to do. But effectively, we don't have much change between the two versions of Xen in terms of layout of the structures.
What is the new version in fact the old version?
Yeah.
Because you only migrate between minor versions?
Yes, this is what we do.
The Vanguard will never be part of the stream because that's not part of the internal state. Oh, I thought you made sure that everything was twice.
Sorry, didn't get to what you said?
Still going to try to make hypercalls afterwards, and those hypercalls will send you different things.
All right. Well, I will be happy to take more questions at the end of the presentation. So let's move on. So I said that we want to replace the hypervisor with limited downtime. And so let's have a look at what we mean by limited downtime. So I don't think that so far anyone has shared numbers about live update. But running that on a QEMU VM using a C5 metal instance, we could achieve live update in less than a second. So DOM0 had at that time 8 gigs of memory. The whole VM had 64 gigs. And then below, when we have guest domains, well, I think we had also 8 gigs per domains. So yeah, we can do that pretty quickly. And this is why I said that it was really quick at the beginning. But still, we could go even further. However, we haven't done that at Amazon. We were happy with the current performance. We met our expectations, and we don't have any plan to go any further. But I will still present you some optimization we thought about to make live update even faster. The first one is about optimizing the transfer of the memory. So as I said during a few slides earlier, we have decided to save the page info before the post of the domain because we have realized that in some cases it is unlikely to change and it was accounting for most of the downtime. But we could go even further. At the moment, the algorithm we have is fairly simple. It just looks at the current MFN and iterates through the list of page infos. And if then the next one is adjacent, then we could just merge the two entries into just one. And with contiguous page info record, this is quite good because we can reduce the size of the stream and take less time to save and restore those information. Sorry. We have also realized that when a guest domain has been live migrated, it is more likely that it has page info scattered, and so it has a larger downtime and larger stream. So what I decided to do, I had a little POC for that, is to sort the page info, because even though we have something to merge contiguous entries, some entries could be also contiguous but not mergeable. So let's consider this example. All of the entries are contiguous in memory. We have a big chunk of memory that goes from MFN2 to MFN5, but unfortunately, because of our algorithm, we cannot merge them in just one entry. So if we decide to sort that, we could instead have just one entry and reduce a lot the size of the stream and the number of entries. And so to illustrate my word, I had, as I said, a little POC that I used, where I used the merge sort algorithm. And so with a DOM that had 2 gigabytes of memory, we went from 1,027 entries to just 9 entries. So it shows that sorting the page infos really help. And so we thought that with that drastic change in terms of entries, we would have great savings in terms of downtime. Well, it is a bit more complex because it is naturally what we had. First of all, sorting is a bit expensive. So the first time I had to run the algorithm and sorting the page infos, I was a bit confused. I thought my VM was not anymore responsive, but it is because it took quite a bit of time to sort all the page infos, which means that DOM0 would have to run in degraded mode longer, so it would have one less pCPU for a longer period of time. And it doesn't reduce the downtime as expected. We have been able to drastically reduce the number of entries, but still the downtime is not as good as we might have imagined. So with the exact same setup on QEMU, we went from 730 milliseconds to 670 milliseconds. So yeah, not as good as what we were expecting. But we could maybe just get rid of sorting the page info. If first of all, during the creation of the domain, we could make sure that all the page list info are contiguous. We could also consider to statically partition the guest domain memory, and we wouldn't have to go through the page list. Instead, we could say this is the start address of the guest domain memory, and it is this big, and we would have just one entry to transfer. Alternatively, we could also try to make things less worse with live migration. Because as I said, when we restore a guest domain with live migration, we would only allocate 4 kilobytes pages. And so that tends to increase the number of entry in the page list and makes the performance worse. So some work has been sent on the mailing list, I think 2 years ago, by someone from Vetus. And I have attached the link on the slide if you want to have a look at it. The other thing we have considered to completely wipe out the downtime is to never post the domains. And this is something I could work on during my internship 2 years ago, so I had to dig in my archive to prepare this presentation. So this is my way to call it. There might be some other project called microxen, but this is just my way to call it. So the idea here is that we never post the domains. We could potentially keep the HVM domain running while we are performing live update and saving the state we need to restoring Xen 2. So the problem is that we have decided to post the domains because some things could be changing, and we have to find a way to transfer this delta even when we keep the domains running. And VM exit that are hard to handle doesn't occur so often. So in theory, we could keep the domains running as long as it doesn't require to drastically modify the stream. We do not need to perform any I/O with QEMU, and the VM exit is trivial enough so that we could handle that in microxen. So let's have a look at what I shared at the beginning of the presentation. I said that at some point we had to post the domains, but instead, what if we were running microxen on the guest domain and keeping it running while we are saving stuff in the tasklet? The save operation could happen in parallel while the DOMU is running. And as long as nothing prevents it to run, we can just keep it running. We would then, as we do with the current solution, jump to Xen 2, restore the state we have saved, and make Xen take over microxen, and that's it. So as a conclusion, it was a very long-term project that proven to be successful at scale. And it is also a very useful mechanism to deploy new version of Xen easily and quickly. And as I said, we were happy with the current performance, which met our expectation at AWS, but we could do some work to further reduce the stream size and maybe avoid posting the guest domains. So that's it, and I would be happy to take any question if you have some more.
So you made a point before about the differences in downtime, where, depending on the number of DOMUs that are present in the system.
Mm-hmm.
Is the scalability limit given by the amount of memory that the domains use, or by the number of domains in the system?
Naturally, I think the main problem is about the memory we have to transfer. So this is naturally about the number of domains. We could have like one domain that use a terabyte of memory that would make live update very, very slow. This is naturally the number of domains, but the quantity of memory we would consume.
But there's no data motion.
Sorry?
But there's no data motion, right?
Yeah, there is not a motion, but we still have to go through the list of page info and transfer that, and then in Xen 2, allocate those page info again and populate them. And that takes quite a bit of time.
Hard close the downtime is basically down zero because PV on your restores all the reference. Yeah. So the more guests you have, the more chance you have mappings in down zero, making things more difficult to transfer.
Fair enough.
Well, I guess no more question. Then, oh, okay.
Oh, yeah. Did you have one?
I was putting it in.
Oh, okay. So, quickly, I noticed you mentioned that at various points that the live update might fail if a guest does certain things that aren't expected. If you're willing to accept a bit more downtime, would it be possible to instead pause sooner and therefore guarantee that
Yeah, and I think it is the version we had a few years ago, and this should be the improvement. I mean, we are happy to take a cancellation and try again to perform lab update. This is not a problem. What we aim to do is to reduce as much as possible the downtime. So having cancellation because something hasn't been able to be posed or the page info has changed, this is not a big problem. We can still try again.
Okay, for instance, a malicious guest might try to repeatedly block live updates so that a security patch didn't get applied, for instance.
I think it's a trade-off between what you want to transfer and what you, like, for instance, for QEMU, there's a lot of stuff you would have to transfer if you have transfer gets. In particular, the OS, etc., there's tests that you have to build, and then you will transfer. We decided to make it simple and say, let's wait. I mean, so far from experience, we didn't see that many people. We didn't see that many people hold on because whatever it takes.
I see.
But yeah, I do agree that the solution we have is not the perfect solution, but that's the problem we want.
Like, if someone decided to attack that, then maybe they could prevent you on some specific versions and copy data. And until they then figure out what the vulnerability was. So if you want to be extra secure, then you would have to have a backup plan. You could try like some number of times, 20 times. And if it didn't work then, well, then you have some trouble.
We have the same problem in South. We have to have some forms in South for like the technical scenario.
All right, any more question?
Is the stuff available upstream?
Not yet. And I don't think we are going to make any effort to get that merged upstream. We might make it source available and publish some stuff, but I'm not even sure. Maybe Julien can jump in and help me with that one.
It's a really big product. As Elias said, it took us nearly 4 years to do this much. We are planning at least to make it available as source, possibly trying to automate the process. How can we manage without managing or not?
Yeah, it's more taking up just examples so other people can see how you do it.
Yeah, I definitely want to be able to use the codes publish so people can see what we're doing. We can get more interest, interesting to more than before.
All right, then I guess that's the end. Thank you very much.